Good morning. In this video, I'm going to talk about distributions of random variables. In particular, we're talking about the normal distribution. And in the last video, I talked about the importance of this special normal distribution, which is a normal distribution with an average of 0 and standard deviation of 1. We talk it as the standard normal, and it's important that we have a special table of these standard normal distributions that I will present in this video. Okay, so this is the table, and it's used to compute probabilities for this special distribution. How does it work? How can we use this table? Okay, well, so look, this is the function of the standard normal distribution. It's represented as n01. It means that the average is 0 and that the standard deviation is 1, and quite often it's represented as z. Okay, so in statistics, when we say z, it's the same as talking about this standard normal distribution. Well, so this distribution has an average of 0, and most of the values range between -3 and 3 approximately. Okay, then, so if I have a value, so this table gives us the area on the right side. So the probability that this distribution is bigger than the value, okay? So this is important. Okay, so for example, what is the probability that this distribution is bigger than 0? So obviously, as 0 is the average, 50% of the values will be bigger than 0 and 50% will be lower. So it is 50%. So if we go to the value 0, we read here 0.5. So this is, it makes sense. So another issue is, what is the probability that this distribution is bigger than 3? So we can see here that this probability is really small. And then actually, if we go here to the value 3, we can read a very small value, which is 0.0013. Okay, and then what is the probability to be bigger than 6? Well, 6 is not in the table, the maximum value is 3, but just if we think with logic, we can say that this value is nearly 0. Or we can think about the probability to be bigger than -6. -6 is here, so bigger than -6 will be approximately 1. Okay, so the values in the first column is just the probability to be bigger than this value that we have here. And then, but we have more columns. So what is the purpose of having so many columns? Well, it corresponds to the second decimal. For example, what is the probability to be bigger than 1.53? So we have to go to the value 1.5, and then the second decimal is 3, so we should go here, 1.53, and then we reach here, and so the value 0.063 is the solution according to this table. Okay, so good. But usually we can say that the first column is the most important to understand how it works. So let's continue. To be less than 6, 6 is here, so less than 6 is approximately 1. What is the probability to be less than -1? -1 is here, so the probability is this area that I'm showing as in shadow or in gray color. So by symmetry, I can say that this area is the same as this area. So being less than -1 is the same as being greater than 1. So now we go here to the value 1 and we read that this probability is approximately 0.16. Okay. Then what is the probability to be less than 0.6? So 0.6 is approximately here. So we apply the complementary event, which is 1 minus the probability to be bigger than 0.6. So we go here, 0.6, and so that would be 1 minus 0.27, and then the result is 0.73 approximately. Okay, so bigger than -1, so we apply the complementary, 1 minus the probability to be less than -1. So this is exactly what I have explained before. So this is 1 minus 0.16 approximately, so this is about 0.84. So, and now, what is the probability to be comprised within one interval? For example, the probability that this distribution is comprised between 1 and 2. Okay, so this is the standard normal distribution with an average of 0. We have an interval A and B. So in general, we have different ways to solve this. We can say the probability to be bigger than 1, which is everything like this, minus the probability to be bigger than 2. Okay, so, but there is another way. We can make the probability to be less than 2, which would be all of this area, minus the probability to be less than 1, which is all of this area. If we make this difference, we will obtain this area in red, which is what we want to obtain. But there is a third way. We can say that all the area below the curve is 1, so we put 1 minus this area on the left, which is the probability to be less than 1, minus this area on the right side, which is the probability to be bigger than 2. So we have these three possibilities. In every case, we can think which is the one that we prefer. It doesn't matter, we can choose one of the three ways. In this case, we have chosen the first one, so bigger than 1. I have this value here, 1 is about 0.16, minus bigger than 2, which is the value that I put here. So we get the solution about 0.14. Okay, a different example is between -1 and 2. So I am applying the first way. So bigger than minus, so more or less approximately, this is what we have. Bigger than -1 minus bigger than 2. Okay, so -1 is the value that I had here above. So we get this as bigger than -1 minus bigger than 2, which is the value that we read here, 2, and then finally we get the solution, which is about 0.82. Okay, so now let's continue with a more complicated example. Imagine that now I don't have this standard normal distribution. I just have another kind of distribution, in this case normal with an average of 10 and a standard deviation of 2. Okay, so imagine that I want to compute this calculation. Okay, remember that in the last video I talked about the standardization procedure, which means that every time that I subtract the mean and I divide by the standard deviation, it becomes the standard normal distribution. So this is the step that I recommend. So here I put 13 minus the average, I divide by the standard deviation, and then it becomes the standard normal. Okay, so I made this separation, and this is 1.5. So now I go here to the column 1.5, and then I read the solution. Okay, then this is a similar example. Imagine to be less than 8. So I recommend that always to maintain this symbol. If it is higher than, here I put higher. If it is less than, I put less, so we never change this. So the procedure is that we put 8 minus the average, we divide by the standard deviation, always in the same way, and then it becomes the standard normal. So it is less than -1. Okay, remember that I explained in the previous slide that less than -1 is the same as higher than 1 by symmetry. So we go here, we go to 1, and then we obtain the solution. Okay, then let's talk about the inverse calculations. What does it mean? So imagine that I want to compute the calculation so that this standard normal distribution being higher than a value that we don't know is a particular value, 0.24 for example. So what we have to do is to find this value inside the table. So in this case, we should go to the table and try to find this particular value. In this case, the value 0.2420 is this one. So the value that we are interested in finding is 0.7. Okay. Then this is a different example. bigger than a value is 0.84. And then the problem here is that we cannot find this value inside a table because the maximum value is 0.5. So we have to think with logic. So now if I make a scheme or a picture about this standard normal distribution, so as this value is bigger than 50%, okay, it becomes that the value A that I have to find is negative, okay? So just by making this picture, I have a very important information. The value is negative, so bigger than this value is 84%. So 84 is bigger than 50%. Okay, so important conclusion, A is negative. So now I have to obtain the complementary area. So this area on the left is about 16%. And now, by symmetry, okay, I find this value inside the table, which is 0.1587, and the value is 1.0, okay? So if I put here the value 1, bigger than 1 is 16%, so by symmetry, less than minus 1 is the same, okay? So, so bigger than 1, this area is approximately 16%, so by symmetry, less than minus 1 is the same. So this is the solution. So we get that finally the value A will be minus 1. And then this is what we have. So the probability to be less than, it's a different example, sorry. The probability to be less than A is 16%, okay? So it's what we have here in this picture. We directly, by thinking with logic, we end up that A is minus 1, okay? So we have the table, but in all cases, that's not enough. So we have to make clear how it works, and in many cases, we have to think with logic. Okay, so I propose you different exercises. It's important to practice a lot with this table. It's important, so because in the exams, quite often we put a problem about the normal distribution, and for sure you have to use the standard normal table. And it's important that you make a lot of practice. So I propose you different examples. So for example, the inverse calculation. The probability to be less than a value equal at 0.7, okay, you have to think it's similar to the calculation that I did in the previous slide. Or the probability to be in that this standard normal is inside a given interval between minus 0.98 until 0.9, okay, or the probability that a normal distribution with an average of 10 and the standard deviation of 2 is bigger than 12.37. Okay, I'm using values with decimals because in the problems it's very, very often that the values were computed with decimals. Okay, here, so I'm proposing different examples. Well, the solution can be checked with the StackGraphics. The StackGraphics is the software that we use for practical sessions, and so I recommend that you make these exercises by hand using the table, and then you can check if the solution is correct by doing this with the StackGraphics. This is how it works, although you will have some guidelines about the use of StackGraphics. Okay, this is the option. There's an option called probability distributions where you can check the normal model. We indicate here that the mean in this case is 15. We indicate that the standard deviation is 3, so that bigger than 8 is the value that we can introduce. So bigger than 8, this is exactly the value that is given by the software, and this is the solution that you should obtain nearly the same value with the table. Okay. Okay, that's it, how it works. And then I'm proposing different examples so that you have to practice. Again, I'm telling you that it is very important that you practice a lot this kind of exercises, because in the more complicated problems, finally you end up with this kind of calculation, so you have to get practice with the use of this table. Okay? Well, and then, well, basically, this is what I have explained about the normal distribution, in particular about the standard normal table. Thank you very much for your attention.